continue the second part of MCQ in power electronics. Hope all of you already seen my first video, and this is the continuation of first one. If you not seen my first one, please go in my playlist and see my video. Now today the question number 13, the peak inverse voltage gets applied to a diode when it is forward biased, reverse biased, in the on state, on a heat sink, and the answer is reverse bias. Okay, actually peak inverse is applicable for peak inverse voltage is applicable in reverse bias condition. It is the maximum reverse voltage which can apply across the diode when it is in reverse bias. Okay, the next one, if a Vm is the peak voltage across the secondary of a transformer in a half wave rectifier without any filter circuit, the PIV is, if the Vm is the input signal, peak input signal, then the PIV is Vm. I already given a list in my first video of the MCQ series. Kindly see the table from there. Okay, and there a comparison is already present in between half wave, full wave, and bridge type. There it is already given that the PIV of half wave rectifier is a Vm. Okay, the next one, in a center trap full wave rectifier, Vm is the peak voltage between the center trap at the one end of the secondary. The maximum voltage across the reverse bias diode is, and in case of full wave rectifier, the reverse peak inverse voltage is 2 Vm. Okay, in case of half wave it is Vm, and in case of full wave it is 2 Vm. Okay, now the next one, which of the following is the major advantage of a bridge rectifier? Then the option is the output voltage is more smooth, no center trap transformer is required, the PIV of each diode is half of that for a full wave rectifier, none of the above, and the answer is option C. The PIV of each diode is half of that for the half wave rectifier, a full wave rectifier. Okay, in case of bridge rectifier, the PIV is half in compared to the center trap full wave rectifier. Okay, the next one, if a power supply has a no load voltage 9 volt and full load voltage 8 volt, the percentage of regulation. Okay, how can you calculate the percentage of regulation? Actually the no load voltage is 9 volt and the full load voltage is 8 volt, so the difference is 1 volt by 8 into 100, so 1 by 8 into 100. Okay, and here the answer is 12.5%. okay, so the difference in between no load and the full load by the full load into 100%. okay, the next one, question number 18, a power supply has a no load voltage 20 volt and the full load voltage is 10 volt. The percentage of regulation, again the same MCQ. So here also 20 minus 10 by 10, so 10 by 10 into 100. okay, so the regulation is 100%. okay, the question answer of the question number 18 is 100%. Now comes to the next question, question number 19, if a power supply has a voltage regulation of 100%, then it is the, and the option is the best possible design, the worst possible design, not a good design, none of the above. okay, and the answer is the, it is not a good design. okay, not a good design, option C. The percentage voltage regulation of an ideal power supply is, option is 100%, 0%, 1%, none of the above, and the option is 0%. actually the percentage of regulation in case of power supply is for ideal power supply is should be 0%. okay, now the next one, an ideal power supply is characteristics by very large output resistance, very small output resistance, zero internal resistance, infinite internal resistance, and the option is zero internal resistance, option C. The next one, a given filter has no load voltage 300 volt and the full load voltage is 280 volt. The regulation of the circuit, again the same sum. So 300 minus 280 by 280 into 100, and the option is option B, 7.1%. Okay, next one. uh, the ripple factor of a power supply is is the ratio of, the ripple factor is the ratio of, and the option is RMS value to the peak value to the DC value, RMS value to the DC value, peak value to the RMS value. Actually it is the ratio of RMS value to the DC value, option C. Answer is option C. Now the next one, the ripple factor of a power supply is measure of its filter efficiency, diode rating, voltage regulation, purity of power output. Actually ripple factor is the measure of purity of power output, that means option D. Okay, the next one, if a rectifier, if in a rectifier ripple voltage is 100 millivolt and the DC voltage is 10 volt, then the ripple factor. Okay, then actually here I have to calculate the ripple factor. So the just we already studied that the ripple factor is the RMS value to the DC value. So here is the 100 millivolt, that means 100 into 10 to the power minus 3 by 10. Okay, and the answer is 0.01. That means the option A is the answer. Actually ripple factor means RMS value which is given 100 millivolt and the DC value already given, that's 10 volt. So it is the ratio of RMS value to the DC value. From there we calculate the value is 0.01. Next one, power supply with a DC output of 140 volt has a 50 Hz ripple of 1.4 volt. The percentage of ripple factor. Here the question is the percentage of ripple factor. So it is given that the ripple RMS voltage is 1.4 and the DC voltage is 140, and okay, so then and actually it is needed the percentage, that means into 100. By calculating this we are getting 1%. So the option is option C. Okay, and it is the same type sum that we previously done. Okay, the next one, question number 27. The ripple factor of a full wave rectifier compared to that of the half wave rectifier without a filter, option A, less than half for the of that of a half wave rectifier, equal to that of a half wave rectifier, half of that for a half wave rectifier, and none of the above. And the option is option A, less than half for that of the half wave rectifier. Okay, and the value is 0 half wave rectifier, the value of ripple factor is 1.21, and in case of full wave rectifier it is 0.48. So the value is less than that of the half wave rectifier. Okay, so the answer is option A. Okay, the next one, if the ripple factor of a rectifier output wave is low, it means that option A, the output voltage will have a less ripple, the output voltage will be low, the filter circuit may not be required, none of the above. And the option is the output voltage will have less ripple. Okay, next one, 29. The ripple factor of a full wave bridge rectifier, I just told the ripple factor of a full wave bridge rectifier is 0.48. Okay, so the answer is option B. For have a half wave rectifier, the ripple factor is 1.21. Now the question number 31. A higher value of the ripple factor of a power supply indicates that the RMS value is equal to the peak value, ideal rectification, poor rectification, none of the above. And the answer is poor rectification. Okay, option C is the answer. Now the question number 32. In a power supply, the ripple factor is measured of filter efficiency, diode rating, voltage regulation, purity of power output. Okay, so the answer is option D, purity of power output. Question number 33. The ripple factor of a filter is directly proportional to the load, inversely proportional to the load. Load depends in simply L and C filters, high for good filters. And the option is load depends simply on L and C filter. Option C is the answer. Now the question number 34. The typical value of a filter capacitor for 50 Hz input is 50, and then the option is 5 picofarad, 5 microfarad, 200 microfarad, 50 microfarad, and the option D is the answer, 50 microfarad. Okay. Now the question number 35. A capacitor filter is used for relatively light loads, high loads, low load voltage, none of the above. And the option is light load. That means option number A. And now the question number 36. A capacitor filter in a rectifier provides good voltage regulation, poor voltage regulation that remains unaffected, none of the above. And the option is good voltage regulation. Okay, that's all for the day, and the next part and the last part will come soon in this series on MCQ on power supply. So guys, please like and subscribe my channel, and please share the video with your friends. Thank you for watching my channel.